for this, the only thing that is remaining for textures is actually to send the texture itself to the shader. What I mean is taking this texture here, load it in the JavaScript side, and then send it to the shader. So that's what I want to do right now. And for that, I want to create a function. I think it's easier. I'm going to create a function here, load texture. And I will assume that we're going to pass a source argument, which is the path of that texture in the file system. And here we have two things to do. We have to, again, load it in the memory, in the main memory of the computer, and then send it to the GPU. So let's do the first part. And let me see. Okay, so we can start by creating. Let's create a WebGL texture. So WebGL has this object that is a texture, and this is lat texture. I think I'm gonna use var here, and I'll explain that later. But I'm gonna just keep it as a var gl dot create texture. Okay. And you're gonna need other stuff. You're gonna have to create now an HTML image dynamically. So the trick here to load a texture is to create an image tag on the website. Wait, let me clear this annotations. So we need to create kind of a hidden, we're gonna create a hidden image tag that will be a HTML image in memory. We're gonna load the texture using this new image tag, but this will be invisible on the website itself. It's gonna be visible only when we use it in the shader. So it's a temporary kind of dynamic image tag. And it works this way. You can call it image and say, or maybe like img tag. And then this is called new image. And then we can set the source. So the image tag has a source attribute, and we're just plugging the first our first source attribute to be the attribute of the image. And by doing this, we are not loading it yet, but we are almost there. What you have to do is you're gonna have to create a callback function. And what this means is this is called onload. Basically, remember we discussed this in the very first lab for assignment 0. Remember I mentioned that the way websites work is we have a client side and a server side, and the client side normally is running on a browser, and then the server is running somewhere else. And so imagine if you're loading a texture, the way the website actually expects it to load is for you to request this texture to the web server and then get it back. And this process obviously is asynchronous because the server might be in a completely other machine in another part of the world. So this can take a few seconds or milliseconds to be loaded. And basically this function onload is the function that gets called whenever the image it could be any, in this case it's an image, but it could be any resource. Whenever the image is ready to be used or has been loaded, this function is automatically called. And then you can process the image somehow or display it or do whatever you want. But it's important to keep in mind that this is not asynchronous. So I'm gonna type this here. This function is called when the image is loaded and ready to be used. And like this can take a few, so take a few milliseconds or seconds. Of course, we're going to be running a server in our own machine. Not of course, but for the sake of this assignment, we're going to be running a server in our machine when you are implementing it. But as soon as you deploy it in your UCSC web page, then the UCSC server is going to be serving to you your image, or to anybody who opens your assignment. And I think that's it. We're going to keep this function empty for now. But this is the code we need to create or load the image in the main memory. So what I want to do here is just console.log image, the object image. So I'm printing here now the image tag, sorry, image tag. So I'm printing here, and this should be image tag as well. Sorry. So I'm going to print the object whenever this function gets called. At this point, let's reload our page and see what we get. We got a bunch of errors. Yeah, we are not done yet, so I can expect that. But I think the main problem, this warning that we are getting here, is because in our draw function, we are dividing this by 6, but this should be 8, right? Because this is the amount of elements per vertex now. And I think it wasn't, so this number was getting kind of a weird number when you divide by 6. Now, yeah, we got rid of one of the errors. And now this error is related to the texture, which I think we're gonna solve this as we go. But at this point, it's gonna stay there. Wait. Yeah, I think this is complaining that there is no texture in the unit 0, which is the GPU unit that stores that image. But let's, as we finish implementing this error, or this warning should go away. But we didn't see this print here, right? Because first of all, we didn't even call this function. So let's call this function, and I'm going to call it in the main function. In the main function, at some point, let's see, we can create it after or before setting our buffers. Yeah, we can do this here. And say load texture, and we're going to call load texture, and here we're going to give the path of our block. And this is images dash block JPEG. Images dot block dot JPEG. Let me just confirm this. Yes, this looks right. Block dot JPEG. No, not black. Block. Block. And let's see. Yeah. Images or not images. Okay, this is, I think this is wrong. Yeah, IMGS block JPEG. Okay, let's try again. Okay, that error got away, but now we got another error, which is the object GL is not defined at line 40. This object. Well, it makes sense because we have a GL object here, and this is defined with let, which means it's only accessible in the scope of the main function. So obviously this one is not here. So what we can do, an easy fix for this, and this makes sense, is to keep GL actually a global variable. We can say here, like we have a global variables. We can say GL like equals to null at this point, but here we're gonna get it. So then it should be fine. I believe even canvas could be a global variable, but let's just add it as we go. Okay. Null of this. Sorry. All right, now at least we get the print, right? Line 50, we get this console log here. So everything is working until this point. We still get that warning because our texture is not yet in the shader. So let's do that now. Any questions before we do that? All right, so let me think. We do have to, okay, so we have a bunch of now functions that we have to write to send send the texture to the GPU or shader. And the first one is active texture. I probably mentioned it before, or if I haven't, I have to say that the GPU has certain slots. It has a few slots for textures. I believe that most GPUs have at least 8 slots for, or 8 units for textures, which means that you can have 8 textures at least loaded at the same time on the GPU. So this means that, for example, if you're making a game, you would only be able to have 8 textures at the same time on the GPU. So at some certain points, of course, most games use more than 8 textures. So what they do is they have to at some point load and unload and load things to the GPU. And obviously this can get slow, or at least slower than real time. So you have to be very clever when you are, if you're gonna make a smooth game, you have to be very clever when you actually unload and load things. Also, something that you can do is you can pack many small textures in a big texture, and we call this a spreadsheet, right? Or the sprite sheet. We call each individual image a sprite, and then we combine them in this huge texture, and now you can have more than one texture in one texture file. It's a very common approach as well to minimize the load time, because the memory in the GPU is limited. Obviously, if you have more fancy GPUs, they have more space for textures, and then you're gonna have to do this less, okay? But this function, what it does is it tells the shader what texture unit is enabled at this point. So you're gonna enable only the texture. So we're gonna call it, this is a macro called texture 0. So now you're activating only one slot or only one unit. And let me comment this line by line. What this does is activate texture unit 0. Second is we have to bind texture, and this is also our unit 0, which is let's think of this as the destination, and this is the source. And I'm going to call this now GL, just so for make it more explicit, I'm going to call this GL texture. And I want to bind whatever is in this variable to go to the unit 0. So here we can say that we are binding the texture we just created to the texture 0 unit. Now we are almost there. But what we have to do is to set some parameters. There is many ways one could map a texture onto an object. And I hope that James talked about this in class, but I'm sure that also the book talks about this parameters. And there's a bunch of filters and interpolation attributes that you have to set, because imagine, for example, if you're mapping a texture that's super large into a small object, or the opposite, the texture is small and the object is large. So you're gonna have to scale this image somehow to make it fit. So how to scale all these questions, they're set, or these parameters are set throughout this function that I'm going to type here, which is called GL text parameter, parameter It's not this one. It's text parameter I. And so the parameters we are saying is GL. I'm gonna type this first, and then we can talk about this texture 2D. So this is the type of parameter I'm setting. I'm setting the parameter for this type texture 2D. And what I want to do is I want actually the texture mean filter. So basically the way you can read this is texture mean filter is an argument or is a parameter of texture 2D. And I want the value of that parameter to be linear. So basically what we are doing here is we are set the minification filter. And basically this is how to reduce the resolution of an image. We are saying that we use this linear interpolation to do that. Okay, and there's other parameters you could change. You could change magnification filter. You can change stuff like how to blend images, or for example, how to read transparency. If you're dealing with, like, for example, transparency in your images, how to deal with them, how to blend things, and there is a lot of parameters, and the book has a list of some of them, probably not all of them, but keep in mind that if you're working with textures, you can set a lot of things, and we don't have time here to talk about all of them, also because we don't need to change most of them for this assignment. But then I believe this is it for parameters. Oh, and it's not get parameter. I think I did it. It should be text parameter. Let me double check. Text parameter. I have an autocomplete here. Parameter. I don't think it. No, underscore. Text parameter. I don't think it has it here, but that should be it. Okay, let's go. Keep going. Now what I need to do is I need to map the HTML image tag to the WebGL texture. Because as it is of now, our actual pixels or our actual colors or the image itself is stored in this tag. So we have to kind of copy to this GL texture here. And the way to do that is gl.text image 2D. Here we have a bunch of arguments. And I think this is worth, because there's too many arguments, I think it's worth reading in the book, or actually reading the reference of this function to understand all the variations that you can do. Of course, here some of these names are self-explanatory, some of them are less, but basically the target is GL texture 2D. The level is, I'm gonna just set this here, it's 0, and I'm not gonna talk much about this right now because let's move forward, and then maybe if you have time I come back. This internal format is RGB. You would have other formats for, like, if you want A, and if you have like a grayscale image, there is other types of this. I think this is actually, this is the wrong autocompletion. Text image 2D. Because this is also a color. And this should be, yeah, I think that wasn't right. Because here I have a bunch of arguments, and this, for example, this next one should be unsigned byte, because this is the type of how you want to read these values here. And then at the very end, we have the HTML image tag. At the very end, we have our tag storing our image. basically, as a summary, we have here the channels in this image. We now don't care about transparency at this point. So it's RGB. The type of data that we are reading, we're going to assume it is an unsigned byte. This is because we don't care about negative values for color. And this is our, let's call this a type. It's a macro that we have to pass called texture2d, which essentially is just a number telling this function that this is a texture2d. And there is textures that are 3D actually. So because there's a lot of things we're not going to talk about, some of these arguments might sound kind of not very intuitive, but as you read this documentation of these functions, you're going to understand more why we are putting these values. But for now, that's all we need. And then finally, we send the texture to the shader using, it's more like read the texture in the shader using texture unit 0. Or no, let's make it send. I think it's better to understand it this way. And then this is just a uniform, right? You're gonna set. Remember, you had this uniform here, uSampler, right? So we have to retrieve this. We have to retrieve this uniform, and this is similar to, let's see, we have another uniform there, right? No, I don't think we have any uniforms at this point. We have the model matrix, so I can copy how we do that. Remember, we have to retrieve that uniform. Where is it? Here. We have to get, I'm going to copy this line because it's easier. So here we can retrieve the uniform location. And this uniform location is now the uSampler. So I want to retrieve that. Where is that line? Okay, here. Sorry. Inside our function, I want to retrieve the uSampler from the shader, and this is our uSampler variable. And now I'm setting that variable in the shader. So this is GL uniform 1I. This is, I don't remember what this stands for, but I'm assuming is, we can maybe imagine this one image, but I don't know why this I. But this is to send a texture, so you do this. This is the texture, and this is the unit. So unit 0, uSampler, and I believe we could use GL under. I think we could do this as well here. Yeah. Okay. And I think that's it. That's all of it for sending the texture to the shader. It's a little bit more convoluted, or there's more stuff to be done when you compare this kind of uniform with other uniforms, because we are reading values from the file, from a file, and specifically we're talking about image files. There's a lot of parameters that are involved with this file, so that's why it's a little bit more complicated. But normally, once you do this part, you don't have to. You can always reuse this function, so you don't have to keep writing these things over and over again. And that's one of the reasons why actually having a function for this is very useful. Okay. But I think that's it. Let me reload, and then we can take questions or bunch of problems.